In this video, we're going to be doing an application problem for graphing an equation. Now, there are basically three common approaches to a problem. There is the algebraic approach, the graphical approach, and the numerical approach. So in a graphical approach, we use the rules of algebra. In a graphical approach, we draw and use a graph. And in a numerical approach, we construct and use a table. Now, really, you should develop the habit of using at least two of these approaches to solve every problem in order to build your intuition and to check that your answer is reasonable. So we're going to go ahead and look at our example problem here. So here we have a runner that runs at a constant rate of 4.8 miles per hour. We're going to write the verbal model and algebraic equation relating distance, run, and elapsed time. Then we're going to use two of the approaches above to answer two questions. So let's begin by writing a verbal model and then an algebraic equation relating distance, run, and time elapsed. So our verbal model, we're going to call it VM, verbal model, is going to be our distance equals our rate times our time. So there's our verbal model. Now we also want to have an algebraic equation that represents this. So our equation, we'll use the letter E for equation. So our equation is going to be D equals R times T. Now we know how fast this runner is running. This runner is running at a rate of 4.8 miles per hour. So that's our rate. So we can actually fill this in a little bit better and have that our distance equals 4.8 times time. So we're going to use two of the approaches above, either our algebraic approach or our graphical approach or our numerical approach. So I think that we'll use an algebraic approach and a graphing approach to answer these two questions. Okay, so let's look at our first question. Letter A, determine how far the runner can run in 3.1 hours. So here, we were given a time. In other words, we have a t variable here. And so to solve this algebraically, we would simply put this into our equation. Distance equals our 4.8 times our time, which is 3.1 hours. When we plug that into our calculator, we're going to get a distance of approximately 14.9 miles. Now we can check this graphically as well. So what we're going to do is we're going to answer A and B separately, and then we'll pull them up on the, well, let's just do it now. So here's our graphing calculator, and we're going to go ahead and we're going to plug in our equation. Distance equals 4.8 times t. And a y will be our d and the x will be our t. So y equals, or d equals, 4.8 times t, or our x. And then we're going to go ahead and we're going to graph this. Now we're going to have to adjust our window a little bit so that we can make sure we can see the value 3.1. So we might even want to zoom in. So we're going to go to window, and instead, you can't have negative time, so we're going to put time of 0, and we'll have it go to, let's say, gosh, 10 hours is fine, counting by 1. And then for the y minimum, you can't have negative distance, and let's go ahead and we'll put 0. We can start with 0, that works. And then we'll count by 1s. So now when we hit graph, we have a little different visual model. It looks like we didn't need as much right here in our x's, so we have a choice. We can go back into the window and get rid of that and make it a little bit easier to see, or we can leave it. I'm going to go back into the window, go to the x's, and I'm going to change it to like a 5. So we have a little bit better angle here. Now what we want to know is we want to know when does t, right, when is t 3.1, what is y? What is y? Or in this case, what is our d, right? So what we're going to use is the value feature on the calculator. Now there's not a button that says value, you just have to go somewhere else to get there, like a sub menu. So we're going to hit second trace, and that's going to be the calculations menu. And here our first one is the word value. We want to calculate the value. So we hit enter, and we want to know when t equals 3.1, what is y? So we'll plug it in, and it's going to tell us that our y is about 14.88, right? About 14.88. So we can write that down. So it said d is about 14.88, which when we round that to one decimal spot, we get 14.9, just like we did algebraically. So we can see that we did it correctly. Let's answer our second question. Determine how long it will take the runner to run 26.2 miles. Now here, this is not time, this is distance. So this is going to go in for our D. So 26.2 equals 4.8, and we want to know how long is that going to take. So algebraically, what we're going to do here is we are going to divide both sides by 4.8. When we plug that into our calculator, we're going to get a time that is going to be approximately 5.5 hours. Okay, 5.5 hours. So now we're going to do this graphically. So we pull up our graphing calculator, and this time we want to make sure that we can get all the way up to 26.2 on our y value. So if we change our window, where we know that our maximum needs to be a 26.2, and we can kind of use the answer 5.5 as a guide for us, okay? So we know that we need to go up to about 5.5 hours, and that's our x. So I'm going to take my x all the way up to the number 7 for 7 hours. And you know what? If my y that we're looking for is 26.2, I probably want this value here to be a 30 so I can actually see it. Okay? So that's a lot of numbers. Let's count by 2's for our y scale, and then let's hit graph. So we're going to use the trace feature here to arrow over to 26.2. So we're going to hit trace, and then we're going to arrow over until we get all the way up to 26.2 for the y value. So I'm at 24, 25, oops, 26.4, go backwards one, 26.2. Now it's not exactly 26.2, but that's okay, it's close enough. Take a look at what our x value says. Here it says x equals 5.46. 5.46. So here our calculator is telling us that we've got about 5.46. And when we round that, that's going to give us approximately 5.5. And so here we see, just like before, that these match. So we know that we've done it correctly. And so that is one way that you can utilize the algebraic approach and the graphical approach for an application problem to solve the problem and then to check your answer.